Welcome back to Common Core 1.2 Part C. So we're going to talk about square roots. Now, what exactly are square roots? Well, if you remember what a square was when a number was multiplied by itself. So 5 square would mean 5 times 5, so 2 5s being multiplied. And I'm sure you remember that. Well, two more examples of this would be like 5 to the third power would be like 5 times 5 times 5, and 2 to the sixth power means 6 2's all being multiplied. So again, that's stuff we've covered. Well, what's even easier is that we're only working with squares, which means there's only going to be a 2 in the expo column. So like 8 squared, 2 squared, 4 squared, whatever the number is, it would just be times itself. Well, a square root simply reverses the process, so just like multiplication and division does. Just like where 5 times 5 is 25, division side would be 25 divided by 5 is 5. So it's the same equation, it just got flipped around. And that's a thing called a fact family, where if you have 5 times 25, you have 2 5s and a 25, and you just switch the actors around to make a division problem. 25, you go here, and we'll divide by 5, and that's going to equal a 5. Alright, so forget that. Take 5 and multiply by 5, and then 25, you go here. So that basically is a fact family, how they can all be switched around. So a square root is the same, it's just the opposite of a number square. For instance, start with 3 square. So what's 3 square? Well, 3 square is 3 times 3, and of course 3 times 3 is 9. Well, in that same way, if 3 square equals 9, then it took 2 3's multiplied to make 9. So a square root just starts with the number that had been multiplied, which was 9. So we'll just put it in this square root sign, and it's going to look like this. We just put a 9 on the inside. So square root of 9. Okay, now what? Well, simply what times itself would make an answer of 9. Now we just discovered that 3 times 3 was 9. So we just did 3 square, that should be a little 2 there. 3 square equals 9. So obviously the number 3 was what was being multiplied. Therefore, the square root of 9 makes 3. I know this seems kind of excessive for some, but I wanted to break this down as small as I could to make it easy for folks who might be having some trouble with square roots. So, example. Square root of 25 is 5 because 5 times 5 made 25. And the square root of 81 is 9 because 9 times 9 makes 81. I think you see a theme here. And root of 144 is 12 because 12 times 12 is 144. So what if you don't know the answer in your head? Well, you can just find the root on your calculator. Now, most calculators will have a little square root button. They might be above where you have to hit a shift key. In class, you can ask me your individual calculator. I should be able to find it without too much trouble. So you go ahead and try these three. Root 25, root 81, root 144. If you don't remember, well, they were just on the last one, so hopefully if you were paying attention, you would know that's 5, 9, and 12. Skills practice 1.27. Try these three. So write them down if you want. Separate sheet of paper, extra credit, turn them in. Root 121, root 196, and root 225. Go ahead. You get 11, 14, and 15. Since we have a handy button in your calculator for this, we can do almost any number. For instance, if I said take a root of 0.25, I don't expect you to be able to do that in your head per se, or even do it on paper. You could just take, well, the root of 0.25. Whoops, let's try that again. The 0.25 square root. And you get 0.5. Well, let's take a look. So, you just got 0.5. Now, why is that, by the way? You might say, how is that possible? Well, 0.5 times 0.5, remember, 5 times 5 is 25, and you have 1 and 2 spaces over, so 1, 2 would make 0.25 just where it came from. I know we didn't do a lot of decimal work because, again, Common Core means we have to move a little faster. If you have questions on that, I'll be happy to answer it tomorrow. That's okay. So you try 0.81, 0.0144. Those two, go ahead and try them. And I'll show you how to do them. 0.81 is 0.9 because 0.9 times 0.9, now it's funny I should put little times here, times 0.9 is going to be 0.81. And this 0.0184 is going to be 0.12 because 0.12 times 0.12 equals 0.0144. How is that possible? 1, 2, 3, 4. 1, 2, 3, 4. 0.0144. Skills practice, try these. 0.0169, 0.0025. Alright, 0.0169 is 0.13 and 0.0025 is 0.05. Now, here comes the part that might throw you for a loop. Again, I don't expect you to know every fraction that will be. That's why you have a calculator if you need it. But the root of 1/4. For most calculators, you hit the square root button. You push the 1 and then what's called an ABC button right here. And then the 4 and hit the equal sign. Hopefully it should say 1/2, which probably looks like 1 and then this button here. Let me refresh you. Let me run that back again. Root of 1/4. So you could hit the root button, 1, ABC, 4, hit the equals, and it should be, says this, which is 1/2. Now you try. So go ahead and you try square root of 1/9 and square root of 144 over 169. Go ahead. I hope you know that this becomes 1/3, and this becomes 12 over 13. Now let me give you a shortcut real quick. See how you have 9 here? Well, you know that 3 times 3 makes 9. Therefore, you know the bottom's going to be 3. What times what makes 1? 1, because 1 times 1 is 1. Same here. What times what makes 144? 12. What times what makes 169? 13. So you have 12 over 13. That's an easy way to do it if you happen to know what two numbers multiplied make a number. So there you have that. Skills practice. Go ahead and try these two and go. See how you did. 4/9 and 11/15. Now for another loop. When you have this, remember the negative has to wait. So just before, what times what makes 25? You know it's 5. You know, I'm not sure if I want to do it this way, but yeah, -5 times -5 would also make a positive 25. So in other words, you'd have two possibles. Well, what times what makes 25? That's 5. The negative waits to make it into -5. Also, what they're trying to say here is, just like 5 times 5 makes 25, -5 times another -5 would make 25. In other words, to find 25, there's two possible answers. There's 5 times 5, which is 25, and -5 times -5 also makes 25. And here they're asking for the negative version. So here, you would know that 15 times 15 makes 225, or you could calculate, and negative says make it a negative. That's the first way, which is fine. Or the other way is saying what negative number times another negative number would make positive 125, and that also gets you to -15. Now 625, you might have to play with your calculator, or you might know it's 25. Negative makes it a negative, or simply -25 times another -25 would make that positive 625. So no matter how you look at it, you're going to get -25. They're calling for a negative, basically. Second look, this is where we're doing it. You just separate the 25 and the negative, root 25 into 5, negative weights, slaps it together. Either way works. You're going to use both for Algebra 1. Remember that you have to have the negative on the outside. You cannot have it on the inside, because no number multiplied is going to make -16. You would say, well, what about 4 and -4? Yeah, but those aren't the two same numbers. 4 and -4 are different numbers. If you have two -4s, it's going to make a positive 16. If you have two positive 4s, it's going to make a positive 16. So negative has to be on the outside. This is no. This is yes. So once again, negative has to be on the outside. You cannot have a root of a negative number. Now let's put it together. So if I ask for a positive and negative of root 25, the quickest way to do it is just to root 25. I'm just going to save you all this work down here. Root 25 into a 5 and put plus and minus. And what that means is positive 5 times positive 5 is 25, and -5 times -5 could also be 25. So let's just skip most of this. Positive negative root of 25 is positive -5. And we'll just leave it at that. Let's just skip all this here. Although this is kind of interesting, because when you get -5 and 5 as your answer, when you have x squared equals 25, and I said that either 5 or -5 works, that's because if you go back to -5, all the way up here will be positive 25, and a positive 5 all the way up here will be positive 25. So it's going to jut up like this basically. And that's the reasoning. If you notice, when I do this graph for you, all the way over to 5 is 25, all the way over to negative 5 is positive 25. Notice how there's no negative 25 though. It doesn't go down because two negatives make a positive and two positives make a positive. Positive growth, growth of human population over time, and negative growth are increasing national debt. But that's a whole different tirade that you don't need me to get on about. Funny how this is only 15 trillion and this is 2012 and now it's 20 trillion pretty much. Interesting. Anyway, one more thing. I told you how we could do this. Well, I already showed you the shortcut just to root the top and bottom, so I'm going to make it easy on you. You have root of a fraction, you can just do this. Take each root at a time, which I was kind of telling you to do. Root 144 into 12, root 169 into 13, voila. There you go. Trying to save you some time. Now, what happens if you don't have a perfect square number? Well, alright, if you root 2, take your calculator. Root of 2 is 1.41 blah 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 blah. This is called a non-perfect square root. So you just round it to whatever you want. If I say round to the nearest tenth, you're like, okay, well, this is the 10th and this would be the 100th. Is this 5 or more? Nope, cancel it. 1.4. If I say to the nearest 100th, well, okay, you would take this. Let me just copy this, in fact. So the nearest 100th, well, let's see here. We would say tenths, hundredths. Is this 5 or more? Nope. Cross it out, etc. Look at the number line again. Where's the root of 20 fit? Well, root 20 for me. You take 20 and square root it, 4.47, or whatever you have in your calculator. You just drop it in. Somewhere about here is fine. Again, you don't have to be perfect. Anywhere close is perfect. And that'll end our lesson, so yay for that. We have some things to go over tomorrow. Talk to you then. Bye.